Welcome to Integration by Substitution Part 2, and in this part we're mainly dealing with trigonometric functions, the square trigonometric function, the compound angles, and the products of sine and cosine. So here we're going to handle three parts. The first is compound angles. Then we have the square trigonometric functions, and then we have the products of sines and cosines. So we're going to use examples. Kindly follow along, and if you have any questions you can reach out to me directly via the contact I've provided. So we are starting with compound angles. So these are trigonometric functions that contain compound angles. Let's go to our examples straight away. So we're starting from the simple ones as we move upwards. So example 1, integrate sine 2x dx. Our first step here is to let u to be equals to 2x. That means du will be x will be 2 dx, and then we're going to have dx to be du over 2. So that means we are having sin u and then du over 2. That gives us a half sin u du, and that gives us negative a half cos u plus c. But we already know what u is, so if we substitute, you get negative a half cos 2x plus c. So that's how we do that. Our next example is you're given sine 4x plus 3 dx. So our u is 4x plus 3. Our du will be 4 dx. That means dx is 1 over 4 du, or you can simply say du over 4, and don't forget you can use any letter you want. So that gives me the integral of sin u times this is 1 over 4 du. A quarter is a constant, so we put it out. We are getting sin u du. If you integrate, you will get minus a quarter, because if you integrate sine, you'll get minus cos u plus c, which is simply minus a quarter cos 4x plus 3 plus c. So that's how we solve. And like we said, you're moving from less complex to more complex. Our next example is on the squared. So we're going to have example 3 is the integral of sine squared x dx. We are going to apply trigonometric rules. We know that sine squared x is the same as a half into 1 minus cos 2x. So we are going to make this substitution. So whatever we have sine squared x, we're going to replace with that. It's an indefinite integral, so a half is a constant. We have integral of 1 minus cos 2x dx. So we integrate. We're going to get a half into, so when integrating, we will integrate separately. We will integrate 1 dx and then integrate cos 2x dx and get. So if you integrate 1, you're going to get a half, or not a half, so we're going to get x minus. Remember previously, if you integrate cos 2x, you're going to get a half sine 2x. So here we're going to get a half, like we have shown when we began this video, a half sine 2x, and then plus c. So if you expand, you get a half x minus a quarter sine 2x, then plus c. So the same thing applies for the squared of cos and the squared of tan. So we'll just handle the both so that you can see what we mean. So here we have the integral of, so here on our example 4, integrate cos squared x dx. But we know that cos squared x dx is a half into 1 plus cos 2x, the half angles. So we are making that substitution. We have 1 plus, so we are factoring a half outside. We have 1 plus cos 2x dx, which you're using the same procedure. You integrate 1, you integrate cos 2x, you're going to get a half into x plus, if you integrate cos 2x, you're going to get a half sine 2x. How we are getting that, I have explained. And then plus c. Why plus c? Because it's an indefinite integral, so c cut us for that. So you're going to expand and get a half x plus a quarter sine 2x plus c. And now that's it. So for tan, the same thing happens. You make the substitution for tan squared, which is 1 minus secant squared. So next, you're going to check out the examples for our last thing, which we said is angles of product and sine. But before anything, we are going to start with the integral of sine 4x sine 2x dx. That's the first thing we are starting with. So we're going to use some formula here, which is quite simple, though you can use any other method. So we are saying that cos alpha, it's a trigonometric function, minus cos beta is the same as 2 sine a half into alpha plus beta times sine a half beta minus alpha. So this means, and then we also have another function that a half cos alpha minus a half cos beta. So this, we are simply dividing both sides by 2. We're going to get sine a half into alpha plus beta, and then sine a half into beta minus alpha. So what happens here, we already know that we have alpha and beta, it's 4x and 2x. So we are saying alpha plus beta over 2, this part here, is equals to 4x. This means alpha plus beta is 8x. And then next we have, okay, so this over covers for everything. So to avoid confusion, let's just rewrite this properly. So this is alpha plus beta over 2, and then we have alpha, no, we have beta minus alpha over 2 is equals to 2x, this other part here. So that was our first part, and now this is our second part. So that means beta minus alpha is equals to 4x. So this is equation 1, this is equation 2. If you solve the 2 by elimination, which is quite simple, you solve it simultaneously. So here we are solving simultaneously. We're going to get alpha is 2x, you're going to get beta is 6x. What remains is to substitute back in this equation. So you're getting the integral of sine 4x sine 2x can be simplified into, remember we have a half here, we have this, a half is common, so you're saying a half into the integral of cos alpha is cos 2x minus a half into the integral of cos beta, but cos beta is 6x, everything is dx. So here we also have dx. Now you can see that the integration is very simple. If you integrate this, you will get sine a half sine 2x. So a half times a half, so you're going to get a half into a half sine 2x minus a half into 1 over 6 sine 6x plus c. And now this gives you 1 over 4 sine 2x minus 1 over 12 sine 2x plus c. So that's simple, very simple, very simple. So you use the appropriate substitution. And now our next is on the powers of trigonometric functions, where we find that one maybe cos is raised to a power and then sine is not. So that's our example 6. We have the integral of sine 5 raised then cos x dx. You see, it's cos x dx, meaning u must be sine. So we say u is sine x. That means du is cos x dx. So if you substitute back, you will get u to power 5 du. You integrate, you'll get u to power 5 plus 1 over 5 plus 1 plus c, which is simply u to power 6 over 6 plus c. We are putting that c because it is an indefinite integral. So we are getting sine power 6x over 6 plus c. We have substituted back. Whatever we have our u to power 6, we're putting there sine, so it becomes sine to the power 6. Another case is, now this one is our example 7. We have the integral of cos squared x sine x dx. So this one is not indefinite, this one is definite because it has powers. So sine x dx tells us that if you want to get sine x dx, u must be cos. So u is cos x, du will be minus sine x dx, and then you make your substitution. So you're going to get pi over 2 0 negative u squared du. If you integrate, you will get negative u cubed over 3 from 0 to pi over 2. So if you substitute, u is cos. So this one is cos cubed x over 3. And now the substitution is from 0 to pi over 2. Pi over 2 is 90. So we are going to get negative, you are going to simplify. Negative, if we substitute by pi, we are getting cos cubed pi over 2, which is 0, minus cos cubed 0, which is 1. Everything here is over 3. So we are going to get negative into 0 minus a third. That is simply a third. So that's the trick, you check. But now we have our last example, which is a bit tricky. Example 8, we are told to integrate from pi over 4, which is 45. We have tan squared x secant squared x dx. So you can see here we have everything is squared, but if you check closely, you realize here we have sec squared x dx. So meaning you can get secant squared x dx if we differentiate tan. So our u becomes tan x, our du is secant squared x dx. So if you want to be good in integration, you must as well know differentiation very well, because those two are siblings. So you're getting u squared du. So this one is u cubed over 3 from 0 to pi over 2. But we know that u is tan, so we have tan cubed x over 3 from 0 to pi over 4. Sorry, this is not pi over 2, this is pi over 4. So if you substitute, we are getting tan cubed pi over 4 minus tan cubed 0, each is over 3, and our value will be 0. So we are left with a third. So that's it for substitution. Thank you. See you on the next. Bye.